In this video, we're going to be taking a look at how to factor a quadratic using what's been called the grouping method. The grouping method gives you a sure way to be able to get to your answer without having to do so much guess and check, but it is a process with a number of steps in it that you need to remember. Some people will prefer this method to the typical guess and check. Others will prefer guess and check. That's up to you. But if you do want to see how to do the grouping method, I'm going to go ahead and walk you through what that method looks like here for this very first problem, and then we'll go and apply it just to one other one to see it in action. So in order to use the grouping method, the very first thing you need to do is multiply your a and c values. Remember that a is your quadratic coefficient and c is your constant. So in this case then, 15 times 8 gives us 120. All right, now that we know that, we can actually go back to the normal idea of what adds to this and multiplies to this. It's just in this case, it's saying what two numbers add to our b value, the negative 22, but multiply to our a times c value. So it's like what we did before, except in order to do that multiply part, you're actually doing the a times c to see what to multiply to. All right, so we need to figure out what two numbers add to negative 22 and multiply to a positive 120. Well, if we're adding to a negative but multiplying to a positive, that tells us that both of those numbers need to be negative. And so then I'm thinking about 22 and 120. Well, 120, the numbers that jump out to me first that multiply to 120 are 12 and 10. So I might try that first, like negative 12 and negative 10, which does indeed add to negative 22, so that's my winning combination. So I've now identified what two numbers add to b but multiply to ac. What I do with that then is I'm going to split my b value here into those two parts. So I rewrite my equation where everything is the same except that the b value is now split into those two components. So in other words, this became this. Now, why do we do that? Because we now are going to factor terms 1 and 2. And so when I'm talking about terms 1 and 2, this is what I'm talking about here. And then terms 3 and 4, we're talking about those terms. What we're going to do is we're going to treat each of those two binomials as their own separate binomial to factor. So let's go ahead and start by looking at terms 1 and 2 here. So for terms 1 and 2, what could I factor out of both of those? Well, see the 15 and the 12, that tells me that I could factor a 3 out of both of those, but they also both include x in them. So I'm actually going to be able to factor a 3x out of both of those terms. And so if I do that then, that leaves me with a 5x from the first term. The minus is still a minus. 12x divided by 3x gives me 4. So that first part is done. Now I'm going to go ahead and factor terms 3 and 4 here. Now, notice I made this little note over here to keep the x coefficients positive. That is going to be critical to making sure that everything matches up in the end. So in this case, notice my first term there, that negative 10x, that's negative. I want that to be positive. So when I factor out here, I'm actually going to factor out a negative. So what can I factor out of 10 and 8? Well, I could pull 2 out of both of those. Can I pull an x out? No, I can't because there's no x in the 8. So all I can factor out here is the 2, actually negative 2. And so that leaves me with a 5x, and then the plus 8 becomes a minus 4, because remember, you're factoring out the negative 2 here. Now notice what just happened when we factored that out. Notice that in both of these sets of parentheses that we left behind, we happen to end up with the exact same thing. If you have done your process right to this point, that will happen. If you did this process and you found that the stuff inside the parentheses is different, go back and check your work, because if you do it correctly, it will be the same. And that is what makes this method work. Because the very next thing we're going to do is we're going to factor this. Now, this is a weird way of factoring. It's not the way that we normally do it. But remember that factoring always means to look to see what can you pull out of every single term. And we would basically be saying, well, here's our first term here, and here's our second term here. Notice they both include 5x minus 4. So what I'm actually going to do is factor 5x minus 4 out of both of those. And when I do that, that 5x minus 4, it ends up pulling out front. But then notice what gets left behind there. The 3x is the 3x here, and the minus 2 is the minus 2 there. And so those are the parts that end up left behind, where I'm basically pulling that 5x minus 4 out of both. Complete that picture. All right. And so then that is our factored form. So if you use this method, it will always be able to factor it reliably. The trick is just remembering all the little steps that are involved. Now let's go ahead and take a look at one more example, just using that same method. We're just going to walk through it one more time. If you feel like you got kind of a hang of the method, this would be a great time to maybe pause the video and go and try it on your own first before I walk through the process here. That way you have a chance to be checking it as I go. All right, so in order to do the grouping method to factor this, and yes, you could still do guess and check, remember. This is just giving you another tool if you want it. So we are going to multiply A times C first. So that means I'm going to be doing 110 times 6, which gives me 660. Now I need to figure out what two numbers add to B, which in this case is negative 53, and multiply to AC, which is 660. Notice you're dealing with some bigger numbers here. And yes, you're going to have to grapple with some bigger numbers when doing this work than you would if it was just a plain old x squared at the start. More numbers, harder factoring. After you've done a little bit of searching, you should find that those two numbers are negative 20 and negative 33. So that's how I'm going to break up my negative 53 in the middle of my quadratic. So I split that negative 53 into negative 20 and negative 33. Notice the x's stay with those. Now that I've gotten there, I can go ahead and factor the first two terms and factor the second two terms. By the way, you might be wondering, would it change if I had swapped the order of those two? No, you'll still end up with the same answer. The work will look ever so slightly different in the next step if you had them swapped, but you'll still end up in the same place. All right, so I'm going to factor the first two terms. So I look just at those two and I say, okay, what can I factor out of both of those? And it looks like I can factor out a 10x. So I'm going to be doing 10x and then parentheses. And then I factor out of the last two terms. Notice the first term is negative, so I do want to factor out a negative number here. And then we say, okay, well, it looks like I can factor out a 3 there. And so then I'm going to have something that looks like that. So I go ahead and do that factoring, and then I check. Is the binomial inside the parentheses here the same? And yes, it is. That means we've done our work correctly from here. So now I just have one last, and that is to factor that. And in this case, that means factoring that 11x minus 2 out of both of the terms that we have in our polynomial. And so we end up with 11x minus 2 times 10x minus 3 as our final factored form. And it's done.